Hello everyone, my name is Cristiano Tamborrino and I am a researcher at Università of Bari in the Department of Computer Science. I'm working on the PNRR failed project SPOC6 in the context of Symbiotic AI. And in this poster I will present a new algorithm for dimensionality reduction problems that is called an intelligence Deep-QLP decomposition algorithm with AI application. The idea started from the fact that, as is well known, the main methods still widely used for dimensionality reduction are the principal component analysis or singular value decomposition. And while these methods remain a benchmark for many applications, they suffer from the need to apply specific techniques for selecting the key feature in a dataset. Our approach in an intelligent way with a user parameter tolerance tau is able to find a final matrix that focuses on either the largest or smallest singular values. Here I show the main result of our research collected in this theorem, in particular given a matrix A of dimension m times n that represent our dataset, and given a tolerance tau by the user. Under specific hypothesis, we have that the factorization produced by algorithm approximate the matrix A as the product of Uf, LDF and V transpose F, with LDF that represents the diagonal element of matrix LF, Uf and VF orthogonal matrices, and F positive integer such that the norm 2 of the difference between the original matrix and the factorization is less or equal 3 that multiply the tolerance that multiply the norm 2 of the matrix A. So the algorithm works in the following way. First of all, we start with QLP decomposition that compute 2 times the QR factorization in order to obtain an output of the matrix A that is factorized as the product of the matrix Q, L, and P transpose. And the matrix QP1 and P0 TP provide a good approximation of the left and right singular subspace. So, according with the user tolerance tau, our intelligence Deep-QLP algorithm computes the factorization as I showed before in the theorem. So, the algorithm is summarized as follows. The zero step consists in the performing the Stewart QLP as I showed before. The algorithm then iteratively computes the SVD of 2 small diagonal blocks of the matrix L from the top left and the bottom right corners of the matrix. And then we update the matrix UF, VF, and LF. We perform again the QLP factorization. Then we reduce the matrix size, accepting the largest and the smallest lambda II as good approximation of the singular value if the lower part of L is sufficiently small according to the tolerance tau of the user. So at the end, the algorithm returns the first or last approximated singular values. So to evaluate the flexibility of our approach, we conducted some numerical experiments. Here I will present only 2. In the first experiment on the left, here we consider the airborne leader point cloud dataset, where the task is to segment ground points from aerial points. And this problem was reformulated as a saliency change detection task in image processing, and we have a big data set. We apply our algorithm to reduce the dimensionality, and we obtain reconstructed images, and we obtain a metric, an overall accuracy of 95%, as you can see here in this table. The second experiment on the right, we used the 20 newsgroup dataset, which consists of approximately 20,000 newsgroup documents categorized in 20 topics. So we select 3 categories resulting in 3 classes, and the task here is to apply a clusterization algorithm to this dataset. But before we use our methodology to reduce the dimensionality of the problem, and then we apply the clusterization, and the result evaluated using the common matrix showed that our approach achieved good outcomes depending on the tolerance set by the user. Of course, by adjusting the tolerance, our result could outperform those obtained with, for example, the randomized approach. In conclusion, our factorization method in the context of symbiotic AI should be considered a novel and useful approach with significant implication for real-world AI applications. So this is demonstrated by the numerical experiments where intelligent selection and dimensionality reduction enabled the extraction of the most important information in an explainable way. This work is a joint work with my colleague Antonella Fadini and Francesca Mazzia, and thank you to all of you for the attention.